Let's break something on purpose. We store the word Python in a variable, and then we try the most obvious thing imaginable. Swap the capital P for a J by assigning to the first position. Every other language lets you do this. Watch what Python does when we run it, and it flatly refuses. A type error. A string object does not support item assignment. In Python, once a string exists, you cannot change a single character inside it. That rule is called immutability, and it trips up almost every beginner. By the end of this episode, you'll not only understand that error, you'll see why it's actually a feature. Strings are how Python holds text, a name, a message, an entire file. Over the next few minutes, we'll index them, slice them, transform them with built-in methods, and finally settle that crash you just saw. Let's build it up from the ground. Start with what a string really is. Here's our string, S, holding the word Python, inside a pair of quotes. The quotes are how Python knows it's text and not a variable name. Break it open and it's 6 separate characters in a fixed order. P, RHD, Y, T, H, O, N, N. Each one sits at a numbered position, and Python starts counting those positions at 0, not 1. 6 characters means a length of 6. That length and that ordering are the keys to everything we're about to do. Let's put that into real code. We store the text in a variable called S, one label pointing at the whole string. .upper is a method attached to the string. It hands back an all-caps copy of the text. And len short for length counts Python shouting in capitals, and the number 6 for its length. But here's the detail that matters most. The original variable S is completely untouched. Upper didn't change EOS, it built a brand new string and handed it back. Hold on to that thought because it's the whole point of this episode. Now let's pull out a single character. Indexing means reaching for one character by its position. Square brackets with a number reach straight to that position. 0 gives you the very first character, because Python counts from 0. And a negative index counts backwards from the end, so -1 is the last character. No need to know the capital P from the front, lowercase n from the very end. No loop, no searching. You simply name the position you want, and Python hands you exactly that one character. One character is handy. A range is powerful. A slice puts 2 numbers inside the brackets, separated by a colon, a start position, and a stop position. Here's our word again with every position labeled underneath, 0 through 5. S from 0 up to 3 grabs position 0, 1, and 2. The start number is always included in the slice, but the stop, position 3, is left out. That off by 1 is the thing that catches everyone. The stop index is never included. Let's slice our word 3 different ways. 0 up to 3 gives the first 3 letters, capital P, EY, T. Leave the stop empty and the slice just runs all the way to the end. And this one, colon, colon, -1, steps through pit, then han, then the whole word flipped to noti P. And just like the methods, slicing never touches the original. Every slice is a fresh new piece of text carved from a copy. Every string carries its own toolbox. We'll start from a plain lowercase phrase, hello world, and transform it 3 ways. .upper returns the entire phrase in capital letters. .title capitalizes the first letter of each word, handy for names and headings. And .replace swaps one piece of text for another, handing back the edited copy. Here's the immutability idea made concrete. Replace builds a brand new string with a swap applied, and print shows us that new string. Then we print S again. The first line shows the swap, hello ByteWise, but the second line prints the original, and it's still hello world, exactly as we typed it. The method returned a new string and left the original perfectly intact. That is immutability in action. So how do you build text from pieces? Put a lowercase f right before the opening quote. that single letter switches on F-string mode. We've got two values ready to drop in, a name Ada and a count 3. Inside the string, any name wrapped in curly braces gets replaced by that value when the line runs. Python fills every blank in one clean pass. No plus signs, no clumsy joining, just readable text. Here it is as real code you can run. That little F before the quote is the whole trick. It's what makes the braces active. Each name in braces is replaced by its current value the moment this line executes. One clean sentence with the name and the number drops straight into place. F-strings are how modern Python builds almost every message you will ever print. Now let's settle the crash from the start. You can't edit a character, but you can build a new string that has the change. We don't touch S at all. Instead, we make a new string and a new variable. Take the letter J and glue on everything from position 1 onward. That's the slice S from 1, Jython. Exactly the change we wanted at the start, done the Python way. The original S is still Python, untouched, and we've built a fresh string with a swapped first letter. That's the entire trick behind living with immutability. So here's the one idea to carry out of this episode. A string never changes. Every slice, every method. Every F string hands you a brand new piece of text, and the original always stays put. Here's your challenge before the next video. Take any word, and in a single line, build a new string with its first and last letters swapped. Try it right now. It takes 30 seconds. Next up, Booleans. How Python decides what counts as true and what counts as false, and the surprising everyday values that secretly mean no.